Hello, grade 10. How are you today? Hope you're doing fine. Okay, this is gonna be a really short video. I'm gonna just explain a little bit better about the charge interaction because I guess in the previous presentation that wasn't so clear. So you have some exercise to do about it. So I'm gonna explain a little bit better, okay? Just a review from what we saw in the last presentation. Electrical force is the attraction or repulsion between charges, right? And there is a rule that you need to follow. For example, if I have two charges that are the same charge, what's going to happen? For example, I have two positive or two negative charges close to each other. What's going to happen? So same side, they're going to repel each other. Very good. Okay, so same charge or like sign, they're going to repel each other. And what happens if I have opposite charge? For example, one positive and one negative. So for opposite, what's going to happen? They're going to attract each other. Okay, so this is a really, really important concept that you need to know. Okay, so same charge repel each other and opposite charge attract each other. Now, remember the convention. So for me to represent the electrical field, so like the force that we have around a charge, for example, for positive charge, what's the convention? We represent this electrical field as pointing away from the charge, okay? So it's pointing away from the charge. So for positive charge, the field goes away. And what happens for negative charge? When it's negative charge, points toward that charge. So negative charge points toward, okay? So keep this in mind for you to solve the next exercise. So positive charge goes away. Negative charge goes toward. So here I'm going to show you an animation between the charges, okay? So for example, if I add a positive charge, what happens to the electrical field? Goes away, right? If I add another positive charge, what's going to happen? Also away. And if I put them together, they're going to repel each other. See the charge moving? So they're repelling each other. Okay, now I'm going to clear. I'm going to put again one positive. So for positive, let's go away. Now what happens if I add a negative? The negative points toward, remember? Now if I put them closer, see the attraction? So now they attract each other, okay? Now I'm gonna do the same just with the negative. So I'm gonna do a negative. So what happens to the negative charge? Moves toward. If I add another negative, also toward. And if I put them together, see in the middle, there is no charge forming because they repel each other. Okay? Then you can play with that as much as you want. For example, for positive, moving away here, because in real world you don't have just two charges, you have more. And you can put another positive here, for example, and see what happens, and another negative to see what happens here, for example. Okay? So now you can see all the charges and how they move and how they behave. Okay, this is a really nice simulator you can play, and the website where you can find this is in the description of this video. Okay, that's it. So let's do some exercise together. So for example, what are the charges on each body below? So here I have an electrical field and I don't know the charge yet. How do I figure out, for example, in this scheme? The easiest way is for you to see each side separated. So let's say, for example, for the right body only. So what's happening to the right body? So here is my charge. And what's happened to the electric field? It's point toward or away. So the field is point away, right? So it's point away. So its point away is going to be a positive charge. Remember, positive charge points away and negative charge points toward. Okay, so in this one, I figure out because it's point away, I know it's a positive charge. Okay, now let's look to the left body, to the left side. What's happening here? The field is point toward, so it's going toward. If it's going toward, which charge should I have here? Negative charge. Very good. So if it's point toward, I'm going to have a negative charge. And what's going to happen to them? They're going to attract each other or they're going to repel? What do I have? Different charge or the same charge? So I have opposite charge. I have different charges. So what's happened when I have opposite charge? They attract or they repel? They attract each other. Okay, so from here, for example, you can see they are attracting. Okay, and this is logical because if it's point away from the positive and toward the negative, it's going to attract each other. They are going to be bound together. Okay, that's it for now. Understood? Okay, let's go to another example. So another field, electrical field here. So in the same way, I'm gonna split this in two, right and left, okay? It's gonna be easier. Always do like that, it's gonna be easier. So let's see, let's look just to the right body here, okay? Just to the right. What's happening to the electrical field? It's point toward or away? It's point toward, away, right? So it's going away from the charge. If it's point away, it's positive or negative? Positive charge. Good. So its point away is going to be positive, right? Okay, let's see the left one. So for the left one, what's happening to the electrical field? It's point toward or away? Look in the draw. It's point away as well, right? So it's point away. It's point away. What should be the charge? Positive, right? So it's positive. Now, what happens to these two? They are the same or they are different? They're the same. What happens if they're the same? They're going to attract or repel each other? Same charge, they're going to repel each other. Okay? So, as you can see here in the picture, look in the middle. There is no attraction between them. So, they are like moving away from each other. There is no attraction. They are trying to move away from each other. They repel each other. Okay? There is no electrical field connecting them. That's okay? Good? Okay, let's do a more exercise. For example, 3. Several electrical field line products are shown in the diagrams below. Are they correct or incorrect, and why? So I'm going to show some pictures. You need to figure out if they are correct or incorrect, okay? For example, this one, in diagram A. I have a positive charge here, and the field is point away. Is it correct or incorrect? So I have a charge that's positive and the field is point away. This is correct or incorrect? Correct. Why? Positive point away and negative points toward. Remember? Okay, let's see the diagram B. I have a negative charge here and they point toward, right? So they point toward. So negative points toward. Is correct or incorrect? Correct, right? So positive away, negative toward, always like that. Okay, let's see in diagram C. I have a positive charge. So I have a positive charge, but what's happening to the field? It's point away or toward? It's going toward. Is it correct? No, it's incorrect. Why? Because field lines should point away a positive charge. Okay, so in this case it's incorrect because it's point toward. Should not be like that. Should point away, just like in the diagram A. Okay, a more challenging one. Diagram C. Which charge do I have? Positive. And what's the field is doing? Points toward. Away, sorry. Points away. It's correct or incorrect? Okay, it looks like correct, right? It's point away. But look, I have some that are very close to each other in the right side, and they are in the left side. They are very away from each other. This should not happen because they should be symmetrical. Okay, so when you represent this diagram here, all the fields should be symmetrical in the same distance. So here is incorrect, not because of the direction of the field lines, but because the fields are not symmetrical. So when you represent this field, you should put all of them in the same distance. Okay, should not be like a different distance from like some closer, some more distant. Okay, so they should be symmetrical, and here is not the case. They are not symmetrical. So this is incorrect, not because they are pointing in the right direction away, but they are not symmetrical. Okay? Okay, diagram E. Diagram E, I have a negative charge, points away. So negative charge points away. Is it correct? No, incorrect. Why? Because should points toward, just like in the diagram B. So should point toward a negative charge. Okay, easy? Okay, let's move on. Example 4. Eric drew the following electric field lines for a configuration of two charges. What did Eric do wrong? Explain. So here, Eric, he draw two positive charge, and what's the electrical field doing? Moving away. Okay. Is it correct? Yes, apparently yes. But there is some problem here in this picture. What's the problem? The fields are crossing each other. Should they cross like that? No. So when you represent a field, you always give them space. You don't cross them, okay? Don't write like that. So electrical field lines should never intersect each other. They should never intersect, okay? So Eric, he crossed his line. So this line should not be crossed, okay? So that's the mistake here. He draw a positive moving away, but he crossed two lines. Should not do like that, okay? So when you are drawing, you should give them space. You don't cross like that, okay? Okay, the next one. Consider electric field lines shown in the diagram below. What's the charge from object A and B? Okay, so I have this diagram here, and I don't know the charge, okay? So I have the charge, the object A and the object B. I need to figure out which charge they have and if they attract or repel each other. Okay, the best way is to look at them separated. For A, let's look for A only. What's happening here? What's happened to the field? They are going toward, right? See, they are going toward. If the field is going toward the body A, which charge should I have here? Which charge I have the field going toward? Negative or positive? Negative. Okay, so my A is negative. Good. Now let's look for the B only. What's happening here? What's happening to the electrical field? It's pointing away. So it's going away. See? It's going away. If it's going away, which charge should I have here? Positive or negative? positive charge, right? So I have for B, it's positive, and for A is negative. Okay, now I figure out the charge of them. But they attract or they repel each other? They are opposite because A is negative and B is positive. If they are opposite, they are going to attract or repel each other. They're going to attract. Why? Because they are opposite. And see, here in the diagram, you can easily see how this field is attracting the A together with B. Okay, so that's it. This is really simple. Okay, just do the exercise and you'll be learning this very well. Okay, thank you so much for your attention, guys, and please do the exercise. Okay, thank you. Have a nice day.